Hi, my name is Jason Sekanina. I'm a design engineer of micromodule power products at Linear Technology. I want to tell you about the LTM4676. It's a micromodule regulator that combines digital power system management with a parallelable dual output DC-DC converter. This micromodule regulator delivers dual 13 amp rails or a single 26 amp rail, stepping down from an input supply between 4.5 and 26.5 volts. Its built-in mixed-signal circuits and I2C-based interface enables board-level monitoring, configurability, and fault management using PMBus, an open standard digital protocol. FPGAs, ASICs, and microprocessors are installed on large printed circuit boards, such as the one shown here. These boards can have 30 or more high-current rails powering its cutting-edge digital ICs. The number of rails continues to go up as digital ICs continue to achieve higher integration. As the number of rails goes up, so do the number of things that can go wrong. Rails must be sequenced according to IC specifications. In the prototype stage, ASIC and FPGA sequencing needs might be poorly defined or subject to change. Debugging a system with 30 rails is a real challenge. A motherboard resides in a chassis and might get installed in a cabinet, such as the rack mount system shown here. Often, motherboards, supervisor cards, and other electronics are plugged into a rack mount system. In a data center, you'll see rows and rows of rack mount systems crowded together. This is what's behind the scenes of making cloud computing work, for example. Now picture multiple data centers getting powered by a nearby hydroelectric plant. Here's an aerial view of server farms. Digital monitoring and configurability of board mount power is a key link to minimize downtime and effectively manage vast distributed systems like these. So our focus today is DPSM at the board level. Historically, power supplies are the Achilles heel of any hardware electronics system. They've been incapable of conveying their status or health to the system they're powering, and they're perceived as being low-tech in nature. With the LTM4676, digital monitoring of all its rails is possible and easy to implement. Digital monitoring yields detailed insight into energy consumption, patterns of loading, and long-term trends. A built-in 16-bit ADC lets you read back input and output currents and voltages, output power, temperatures, and uptime. Peak values are readable. Data like this provides us an opportunity to develop predictive analytics and make informed decisions about scheduling preventative maintenance. DPSM is useful during the prototype stages of engineering development. And a fault log feature allows you to retrieve telemetry recorded by the LTM46 devices in the moments leading up to a system shutdown event. This sheds hours or days from diagnosing a problem in high-end systems. Correcting the issue can be as simple as changing some register settings over a PC. And field monitoring and upgrades to a system's power supplies can be realized. OEMs can easily margin rails at ATE to validate board integrity. Linear Technology offers a family of DPSM products. Power Manager ICs to control a DC-DC regulator or LDO, ICs with Power Manager and DC-DC converter combined, and micromodule regulator solutions such as the LTM4676, where the Power Manager and DC-DC converter, including power inductors and MOSFETs, are combined into one package. Target applications for DPSM products include optical transport systems, datacom and telecom switches and routers, industrial test equipment, robotics, RAID, and enterprise systems, places where the cost of electrical utility, cooling, and maintenance are critical. You can count on the LTM4676's performance and configurability over its full specified operating junction temperature range, -40 to 125 degrees C. Detailed derating curves in the datasheet make it easy to design in the LTM4676 and derate according to your ambient temperature requirements. The output voltage is regulated at the point of sense to better than ±1% over temperature, line, and load conditions. Output current readback accuracy is ±2.5% at 10 amps load. This enables excellent characterization and monitoring of ASIC, FPGA, and CPU, GPU power consumption. This, combined with the ability to digitally adjust output voltage on the fly, The LTM4676 opens the door to implement dynamic voltage scaling, load shedding, and other schemes to get the most out of your system. Now let's take a look at some hardware. Here I have a laptop running LT Power Play, a dongle, and 3 demo boards. Up to 4 LTM4676 can be paralleled for 100 amps of output current with best-in-class telemetry monitoring. If desired, the LTM4676 can be paralleled with some of our non-digital micromodule regulators. Power can be scaled up without the overhead of every module providing telemetry. All of Linear Technology's DPSM products can be configured and monitored from one unifying GUI named LT Power Play. You only need to learn one GUI once, and you'll be ready to work with any of our DPSM ICs and modules. Translation from USB to I2C is performed through our DC1613A dongle. A 12-pin connector interfaces from our dongle to our demo boards, but you'll only need 3 pins to communicate to your ICs or modules on your motherboard. 4 pins if you want to configure and store register settings to NVM when input power to your system is absent. So get started with the LTM4676 and dig into digital power system management. Visit linear.com to download LT Power Play, datasheets, and obtain hardware. And be on the lookout for tech clip videos that'll walk you through lab evaluation of hardware and navigating LT Power Play. Thanks for watching.